The man who solved the world's most difficult math problem, Andrew Wiles, a mathematician, solved a mystery that had puzzled mathematicians for over 300 years. The 17th century French mathematician Pierre de Fermat claimed to have proved his theorem, but never wrote down his proof. For over 300 years, mathematicians puzzled over this perplexing problem, which is similar to the Pythagorean theorem but applies to exponents greater than 2. Wiles was a young boy when he stumbled upon Fermat's last theorem at a library in Cambridge, England, in 1963. His determination was extraordinary, considering the brightest minds in math had failed to crack it for centuries. Leonhard Euler, an 18th century Swiss mathematician, proved a specific case where there are no solutions for n equal to 3, but his work didn't extend to other exponents. Paul Wolfskuhl, a wealthy German industrialist, planned to end his life, only to be reinvigorated by Fermat's puzzle, which offered a reward of 100,000 German marks to anyone who could solve it. As a grad student at the University of Cambridge in the 1970s, Wiles was suggested to study elliptic curves, which proved crucial for solving Fermat's last theorem. In the 1950s, Japanese mathematicians Yutaka Taniyama and Go Shimura suggested that for every elliptic curve, there is a corresponding modular form. The Taniyama-Shimura conjecture connected two distinct areas of mathematics. Ken Ribet, a professor at UC Berkeley, linked their conjecture to Fermat's last theorem. However, Taniyama and Shimura never proved their own conjecture. Tragically, Taniyama committed suicide in 1958, leaving a note that read, "I am in the frame of mind that I lost confidence in my future." His fiancée took her own life shortly after, writing, "We promised each other that no matter where we went, we would never be separated. Now that he is gone, I must go too in order to join him." In 1986, Wiles moved to the US, where he was a mathematics professor at Princeton University. He kept his work a secret, not wanting to be distracted, though there may have been another reason for his secrecy. He cleverly threw his colleagues off his track by publishing his ongoing research on elliptic equations every 6 months, making it seem like he was keeping busy while actually devoting his time to the age-old enigma. Wiles began by proving the connection for a specific class of elliptic curves, like knocking down the first domino in a long line. He struggled to topple the rest of the dominoes. 5 years after working in secret, he decided to emerge from his hermit-like state in hopes of finding new ideas. In 1991, he attended a major math conference in Boston, where his PhD supervisor, John Coates, mentioned Matthias Floch's work on a powerful way of analyzing elliptic equations, building on the work of Russian mathematician Viktor Kolyvagin. Wiles realized that this Kolyvagin-Floch method could help him topple the rest of the dominoes, ultimately proving every elliptic equation could be matched to a modular form. In 1993, Wiles sought help from his colleague at Princeton, mathematician Nick Katz, who meticulously checked and verified his calculations. Wiles used a key insight from a paper by American mathematician Barry Mazur to complete the puzzle in May. He chose to present his breakthrough at a conference at the Isaac Newton Institute in June 1993 in Cambridge. At the conference, rumors spread about the Wiles breakthrough on the more than 300-year-old mystery. Wiles recalled that there was a typical dignified silence while he read out the proof and then wrote up the statement of Fermat's last theorem. However, rumors began circulating that there were issues with his proof. Wiles had to address the speculation publicly in a forum at the end of 1993, stating that he believed he would be able to finish the proof in the near future using the ideas explained in his Cambridge lectures. During the review process, a number of problems emerged, most of which have been resolved, but one in particular has not yet been settled. Wiles decided to bounce ideas off of someone he trusted, his former student Richard Taylor, now a Cambridge lecturer, and one of the referees who looked over his proof. They worked through the summer of 1994 without any progress. Wiles was at his wit's end, and thought of giving up. But Richard persuaded him to keep working on until Richard returned to Cambridge in September. On September 19th, 1994, Wiles had an incredible revelation. The Kohlevedian-Flack method wasn't entirely successful. It provided enough insight to revive his original approach using the Iwasawa theory, a theory of analyzing elliptic equations that he had learned as a student at Cambridge. Combining the two methods, which were inadequate on their own, provided the eureka moment. After 8 years of dedicating himself to one task, Wiles' 129-page proof was published in May 1995, putting the greatest mystery in math to rest. Nouriel, Gino Yazdinian,